In this lesson, we are going to review how to write linear equations. We have two objectives. We are going to learn how to write equations in y equals mx plus b form or slope-intercept form. We are also going to learn how to identify the relevant domain and range. So we're going to continue completing our guided notes from our previous module, and in this one we're told to write in a linear equation for each line. So a reminder is linear equations have a y and an x unless they're completely vertical or horizontal. So we need the slope and we need the y-intercept. So in red here, I'm going to just fill in these values. So let's look at line C first. So where does it cross the y-axis? I can see it's crossing at 4, so the b value is 4, and I'm going to count my slope. So I'm going to find one other spot that it hits in the corner, and I can see this is highlighted right here. So as I count my slope, it's going down 1, 2 units, and right 1. Down 2, right 1. So my slope, if it's down 2, would be -2 over 1, and you can reduce that to just -2. So the slope, or the equation of my line, would be y equals -2x plus 4. Let's do line D. So line D is uphill. I know right away it's going to be positive. Slope, where does it cross the y-axis? Down here at -2, so my b value is -2. My slope is, I'll just find another point. It goes up 1, 2, right 2. Again, up 2, right 2. So my rise is 2 and my run is 2, both positive, which reduce to 1. So the equation of this line is y equals 1x minus 2. Now often I won't write the 1, I'll just make it y equals x minus 2. In this next equation, notice that up in the corner I say we're going to be given m and b. So this is probably one of our simpler examples. It says write a linear equation that models each situation. Sketch a graph and write the relevant domain and range as an inequality. So you know from previous units that your domain is all your x and your range is all of your y values. But when I say relevant, we are just concerned about the domain values that make sense in the context of the scenario. So for instance, in real life, if you're talking about time, it doesn't make sense to have negative time. We can't go back in time. There may be quantities when we're talking about maybe it's water. You can't have negative water. All right, so let's read this scenario. It says Julia has $72 in her savings account. She deposits 15 each week. So this here looks like my rate of change, 15 each week. So I'm going to say M is 15. And she's beginning with $72. So if I say that the amount of money she has, if I call this y, is equal to, she begins with 72, and she deposits, it means it's going up 15 each week, and x would be the number of weeks. So I'm going to just sketch, so I don't need to get super accurate here. And if you notice, I immediately only do the first quadrant. A lot of times things only make sense in the coordinate plane in the first quadrant. So x is my weeks, so I'm going to label this as weeks, and y is my money. So she starts with 72, so I'm just going to put a point right here, and I'm going to label that 72. And her money is going up if she's depositing, so I'm just going to put an array here since it doesn't make sense to have a complete line. I'm going to label this point as 0, 72, because it's going to help me talk about my relevant domain and range. So let's do my domain first. Well, my domain is all of the x values that start here and go forever to the right. Okay, so I'm going to say as an inequality, x is greater than or equal to 0. And again, that's in weeks. I mean, think about it. You start at 0 weeks. You could keep depositing infinitely, so it's just x is greater than or equal to 0 weeks. Now your range, where does it begin? This is your y value. So the least amount of money that's in the account is your first $72. So your y, and it's growing, it's getting higher, is also greater than or equal to 72. Okay, and you could put a label on that. I won't penalize you if you don't, but since we're talking about domain and range in real life, it's best with these units. Similarly, okay, we're going to do the same thing here. We're going to come up with our equation, and then we're going to sketch a quick graph, doesn't need to be super accurate, and talk about domain and range. So this one states, a pool with a capacity of 4,000 gallons of water is leaking water at the rate of 5 gallons per minute. So I'm going to say that Y is my amount of gallons, and I begin with 4,000. Okay, at the beginning there's 4,000, and it's losing water, so subtracting at the rate of 5 gallons per minute, so minus 5x. There's my equation. I'm going to sketch what this looks like. So it starts up here. My capacity begins at 4,000, and I'm losing water. So bam, I just put a segment that drops down here. At some point the pool is empty. So again, I don't need to make a line that goes infinitely onward. I'm going to label my points because it's going to help me talk about it. So this first one is 0, 4,000, my y-intercept. Now down here, my x-intercept. Two ways of thinking this through. Some of you are probably just really good at thinking, well, how long does it take to empty the pool, okay? Or you can actually calculate your x-intercept off on the side. So to get an x-intercept, we let y be 0. So if I do 0 equals 4,000 minus 5x, if I add 5x to both sides, that gives me 5x equals 4,000. Divide both sides by 5, and I get x equals 800. So what does this mean? Well, 800 comma 0 would be my x-intercept, and this is the minutes, okay? And over here I have the gallons in the pool. So let's describe our domain and then our range. So my domain values, well, this segment, the least it could be is 0, and the greatest is 800. But remember, x is my time, my minutes. So x is between 0 and 800. Can it equal 0? Sure. Can it equal 800? Sure. So 0 is less than or equal to x, which is less than or equal to 800. So what I'm saying is really it takes 800 minutes to drain the pool. And now when I look at the range, so that's my y values, and the y here is my gallons. So if I think about what are the restrictions on the gallons, well, the least amount of gallons, the lowest y value is down here is 0, and the greatest y value is 4,000. So my y is between 0 and 4,000. And in words, what am I really saying is the capacity of the pool is between 0 and 4,000 gallons. Let's continue writing linear equations. So in this one, we are told that an electrician charges an initial fee plus $26 per hour. If he is paid $263 for an 8-hour job, write a function that models his charges. So as I look at what my given information is, this $26 per hour, hopefully that stands out to you as the slope. Whenever you see something per something, so I know that I'm given M, and it looks to me, I'm not given B this time, but instead I'm given an ordered pair or a point. So I'm given M and a point. Let's write down what that point is. It would be 8 hours, $263. Okay, so meaning that my X represents the hours and the Y is money. It's important that you get that in the right order. So I always write down y equals mx plus b, and I think about, okay, so what do I know? I know my slope, so I'm going to fill in 26 right here. And since I'm given a point, I need to substitute 263 in place of the y. X is 8, and I don't know b. So this is going to help me find b. All right. How do I solve this for b? Well, I'm going to take 26 times 8, which is 208. Recopy the rest of it for good algebraic steps here. I'm going to solve this for b by subtracting 208 from each side, which gives me 55 on the left is equal to b. So now I know my y-intercept. So the equation of this line would be y equals 26x is my slope plus 55. You could also see this written in function notation as f of x equals 26x plus 55. In number 9, we're going to revisit a problem we already did, this Farmer Ellentine one. These beautiful problems from Get More Math. Farmer Ellentine started with some friends on her farm. After 12 days, she had 61 friends. After 15 days, she had 73 friends. Assume a constant rate of change. Write the equation of the line that models this scenario. So what am I given here? It looks to me like I'm given 2 points. So what do I need? I need to find M, and I need to find B. Now, if you took good notes in our previous lesson, you would already have M. You could just fill it in. It was number 3 before. But if you didn't take good notes, I'm just going to quickly fly through this. We're given 2 ordered pairs. The days would be independent, the X variable, and the friends would be the dependent Y variable. All right, so to find M, I subtract my Y's. So I'm going to do 73 minus 61 over 15 minus 12 for my change in Y over change in X would be 12 over 3, which equals 4. So my slope is 4. And again, we did that in the previous lesson. So to find B, again, I write Y equals mx plus b, and I'm going to substitute. I'm going to plug in 1 point for x and y, and it doesn't matter which one you're going to use. So I'm going to choose to go with the first point, just because my numbers are a little smaller, x and y. So I'm going to plug in 61 for y equals 4 is my slope, my m value, and 12 for my x, and I don't know b, it's what I'm solving for, so I have plus b. So now it's just doing some algebra. So 4 times 12 is 48 plus b is equal to 61. How do I solve for b? I subtract 48 from each side, and I get that b is 13. So now I have both components needed for the equation of my line, which would be y equals 4x plus 13 would model the amount of friends on this farm after x days. So it says, how many friends will Farmer Ellentine have after 30 days? Well, x represented my number of days, so I can just take my previous equation and I'm going to plug in my 30 for x, and I do 4 times 30 is 120, plus 13, I get 133 from my y, so Farmer Ellentine would have 133 friends, whatever that happens to be. I wonder if it's a plant, I wonder if it's a weird animal, a vegetable, use your imagination. To check this on your graphing calculator, you can graph any linear equation. These are the graphing buttons right here under the screen. If you hit y equals, this is where you enter up to multiple equations at one time. So we're going to enter our equation we just found, the y equals 4x plus 13. So I'm going to hit 4. Right here is your variable button for x. Hit x plus 13. If you hit graph, you may see part of your line. If you are at a crazy viewing window, the easiest way to adjust it so you can see from -10 to 10 is hit zoom option 6. Zoom 6 will make sure it's adjusted. But I want to check and make sure the points 12, 61 are on my graph. Okay, so several ways of doing this. I'm going to make my window a little bit bigger. So this is telling me I'm seeing in the domain from -10 to +10. I'm going to make this go up to at least 20 so I can check. And I want to go higher with my y. So right now in the range, I'm only seeing from -10 up to +10. So let's change this up to at least like 80, because I know after 15 days she's got 73 friends. So I want to see at least up to 80 so I can see that. So I hit graph, and this is going to change how I'm looking at my line. But now what's kind of cool is my favorite button here is hit trace. And right there, that represents a point 5, 33. After 5 days, she's got 33. As I move to the left and the right, I can see after 5.9 days, she's got 36.6 friends. But I want to know, did I make sure I have this right after 12 days? So after I hit this trace button, if I just hit 1, 2, 12 down here, it types it down here and I hit enter. And there I can see 12, 61 falls right on the line. The other point that was supposed to fall on the line was 1573. So I hit 15, enter, There it is. So I know that y equals 4x plus 13 is indeed the correct line. We were asked after 30 days, how many did they have? So this, I might get an error because it's out of my window. So I hit 30. Yeah, it tells me error. So if I go to, it's telling me, yeah, it's too big. I would have to make my window go as high as bigger than 30. So maybe I go to 50, and then I'm going to go up. I got to go higher on my y's too. I'm going to make it real big. So I'm going to make it 200. And now if I hit trace, I got to let it graph first, hit trace. And after 30 days, we figured out that she'd have 133. There we are. We are correct, right? So it's a great way to check. You get to use it on keystones as well. So big picture, for whenever you were told to find the equation of the line, you need to think, okay, so I need my m value and I need my b value. So somehow you will be able to get m and b from your given information. You may have to use your slope formula to find m, and then you will substitute a point and that m to find b. Okay, you've watched me do it. Now you have got to practice to make sure you understand. If you're struggling, reach out and ask questions.